Hello, we are now solving exponential equations still, but this is when the bases cannot be made equal in our last one. So we have to go through a different process if we cannot get the same base on both sides. So here's the basic gist of how we solve. Okay, the first thing, we have to get the exponential on one side by itself. So basically the item that has the exponent needs to be alone on one side of the equation first. Then, to get our exponent out of the exponent, because we're going to have variables. If you see here, all of our variables are in the exponent. The way we do that is by converting it to a logarithm, because remember you guys, a logarithm is just an exponent. Okay, and then after that, we'll be solving for x. So, let's get going on that. So the first step is to get the exponential by itself, which we've already done that. Check. It's already on one side by itself. Nothing is added or subtracted to it. The next thing is to convert that bad boy to a logarithm. So we'll be on step 2 this time. Convert it to a logarithm. So when we convert this bad boy into a logarithm, so I'm going to set it up real quickly. Alrighty, so first of all, when you guys do this, the log always stays on the same side of the equation as the base. So since my base, which is 5, is currently on the left-hand side of my equation, that's where my log will be. Okay, so remember, the base of the log is the base of the exponential, which the base, if you see here, is a 5. Okay, so that's going to be the base of my log. Okay, and then remember, you guys, these two, the exponent and the 7 will just trade spots. So my 7 is going to hop inside my logarithm. And the x is going to hop on the other side of the equal sign. And holy hot dog, the next thing is to solve for x. Well, guess what, guys? My x is already solved for. There aren't any more x's on both sides of my equation. And nothing is added or subtracted to my x. So that's it, you guys. So step 3. Okay, it's already solved for. So for step 3, I'm going to go ahead and just write my x first, because you know me, I like to write x first. So I'm going to write x first. X will equal log base 5 of 7. And that's it, you guys. That would be the answer. Ta-da! Not so bad. Alright, so that one was too easy. What do you guys think? I think we need to step it up a notch, because the harder the problem, the more exciting the problem. Okay, so let's see here. Now the first thing says to get the exponential by itself. So my exponential has nothing added or subtracted to it. Okay, its exponent has things like that, but nothing is actually added or subtracted to my actual exponential. Okay, so since my exponential is all by itself, the second step is to convert the exponential into a logarithm. So why don't we do that for step 2. Alright, so I'm going to set it up. Remember, the log stays on the same side of our base, which our base is the 3. So it's going to stay on the left-hand side of my equation. Alright, and then remember, the base of my log is the base of my exponential, which, you already guessed it, the base of my exponential is a 3. So that means the base of my log will be a 3. Okay, and then these two right here are just going to trade spots. The 15 is going to hop on the inside of my logarithm. And then the 2x plus 1, which is the exponent, that is the entire exponent, will hop on the other side. Alright, and then from here, you guys, step 3 says to solve for x. So I just need to get x on one side by itself. Okay, so, and I'm going to go ahead and write my x first, because you know me, I like to have my x on my left-hand side. So I'm just going to flip-flop this equation real quickly so it's not irking me anymore. Okay, so this will be our step 3, solving for x. So we have 2x plus 1 equals log base 3 of 15. Okay guys, so all we gotta do is get x by itself. So the first thing we need to do is move the 1 to the other side of our equation. So the opposite of positive 1 is negative 1, so I'm going to subtract 1. Okay, now I'm just going to subtract 1 on the end, and I'll explain that in a moment. Alright, so 1 minus 1 cancels and turns to 0. Okay, so on this side, I'm left with 2x equals, now, You can never, ever, ever, ever subtract a number into a log. Not allowed. Okay, remember the only time we can combine things with logs when we have subtraction is if we have a log minus a log. And then we can use the quotient property. But right now you can never just subtract this 1 to a log. These are not like terms at all. Okay, so I have to leave them separated because they are not like terms at all. Not even close. So we have log base 3 of 15 and then minus the 1. Alright, so we're so close to getting x by itself. So secretly, this x and this 2 are multiplying to each other. So the way we move it to the other side is by dividing that thing on both sides. And I'm going to divide the entire other side, so the whole thing. Okay, and 2 divided by 2 cancels and turns to 1. Okay, so what I'm left with, I'm going to bring it up here since I'm running out of space. Okay, so on this side, I'm left with x equals log base 3 of 15 minus 1 divided by 2. And that will be my final answer, you guys. You can't simplify that further. So we have log base 3 of 15 minus 1 all over 2. Okay, you can never divide into a log, so even if this was something that 15 or the 3 were divisible by, do not do that. That's when the demon cats will get you. Okay, whenever you guys are dividing by a number, if you're going to simplify this down, you have to be able to divide every single number in your numerator by that number. Okay, which log base 3 of 15 definitely can't divide by 2, and 1 can't divide by 2. So, just leave it alone. And all of that right there, in all of its glory, would be your answer. Bam! Awesome, awesome. Okay guys, so I still don't think that was hard enough. I think we still need to step it up a notch. What do you guys think? I knew you were thinking the same thing as me, so let's keep going. Okay, so now, let's look back at our steps. So the first step, get the exponential by itself on one side of the equation. Currently, do you guys see this mysterious 3 right here? Okay, that is currently adding to my exponential, which that is not allowed. Okay, I cannot convert this thing into a log until that is dealt with. Okay, my exponential has to be completely by itself before I convert to a log. Okay, so I'm going to start by subtracting that 3 to the other side. Alright, which 3 minus 3 is 0, cancels out, turns to 0, and 12 minus 3 will give me 9. So currently I have 6 to the x plus 1 equals 9. Okay, so that was step 1. Step 1 was getting that by itself, so if you want to call that step 1, go ahead and do that. Okay, so now that our exponential is by itself, the next thing is to convert that bad boy into a logarithm. So let's move on to step 2. Okay, so remember, I'm going to set this up. The log stays on the same side as your base, so it's going to stay on the left-hand side. Alright guys, and remember the base of the exponential is the base of the log. So the base of my exponential is a 6. So that will be the base of my log. And then remember you guys that these two will just trade places. So the 9 is going to hop inside of my logarithm. And the x plus 1 is going to hop on the other side. Okay? Alright, and then after we convert this into a logarithm, we have to solve this bad boy for x. So step 3, I'm going to go ahead and put step 3 on the other side of my paper since I'm already running out of room. I write big, you guys. I apologize. So, we're going to move it up here. Like so. Bam. So our step 3. Okay, we got to solve this for x, which, you know me, I like to have x on the left-hand side. So I'm going to go ahead and rotate this equation around using the symmetric property. So we have x plus 1 equals log base 6 of 9. So I took this equation and I just flipped it around using our symmetric property. Okay guys, so the only thing we gotta do, we gotta get x by itself, which currently this 1 is irking me and it's getting in the way. Which the way we move that over, the opposite of positive 1 is a negative 1. So I'm going to subtract the 1 on both sides of my equation, which I'm going to write it just like that on this side. And it'll be very similar to why we did that up here, but I'll re-explain that. So 1 minus 1 is 0. It cancels out. So I'm left with x on this side. So So x will equal, and then remember you guys, this you cannot combine. You can never, ever, ever subtract a number without a log to something with a log. They don't get along, it's not allowed. Okay, so I must leave that alone. So this would be my final answer. X equals log base 6 of 9 minus 1. And that'd be it, you guys. Bam! That one's done so. I hope you guys have had as much fun as I had, because I had an amazing time.